According to the law of energy, the number of vibrational modes of a polyatomic gas constant is Cp over Cv. And here we have to select which is correctly representing the relation of a gas constant. It's known that for a polyatomic gas, the translational degree of freedom will be 3. And in the case of rotational degree of freedom, we can say 3 because we are assuming that a non-linear molecule is here. And we know that the vibrational degrees of freedom can be written as here. It's known that based on the degree of freedom, the total energy can be written as 3 over 2 kB T plus 3 over 2 kB T plus F kB T. So this can be written as 3 plus F times of kB times T. So this is a value of total energy of a system. So the molar specific heat at a constant volume is nothing but Cv is equal total energy over time. So here we can write 3F, 3 plus F kB times T over T. So here we can write the molar specific heat at a constant volume is equal 3 plus F times kB. So here our question is about to calculating the value of gas constant gamma. So here it's given that it's equal to Cp divided by C. So it's known that Cp is always equal to 4 plus F times R in terms of polyatomic gas. So let us apply the value. So gamma will be equal to 4 plus F times R divided by 3 plus F times Kb. So when we are simplifying this, we will get the value of 4 minus 3 gamma divided by gamma minus 1. So the correct answer for this question is option C here.